Hi everyone, this is Mrs. J, and today we're going to start talking about trigonometric integrals, specifically sine and cosine. I have a quick warm-up for you guys, so please pause the video and give it a try. Alright, go ahead and check your work here. So one of our trigonometric identities is that cosine squared of x is equal to 1 plus cosine of 2x over 2, all over 2. So if you rewrite it like that, you can factor out the 1/2, the constant, and then this is something that you can find the antiderivative of. You could use u sub here, but this I think you could also do in your head just using chain rule working backwards. And here's your general antiderivative. For part B, I gave you the hint to let u equal sine of x. So that allows you to substitute out cosine of x dx for du, and then you just have integral of u cubed. So take that, find that antiderivative, and substitute back in for u. And then for part C, here if you set u equal to tangent of x, it's a pretty nice problem because du is secant squared x dx. So it works out really nicely for the u sub, and then you end up with 1/4 tangent to the 4th x plus c. So all of these things that we're using in the warm-up, we're going to use pretty heavily today. So make sure, if you're a little iffy on any of those, make sure you go back and review them. All right, so today we're going to be talking about strategies to help us integrate when we have products of sine and cosine within our integrand. There's a few different cases. So if we call m the degree of sine and n the degree of cosine, there's again a few different cases here. So if n is odd, meaning you have an odd degree of cosine, our strategy here is to we're going to replace all but 1 power of cosine. So we're going to essentially pull out the even powers of cosine and leave cosine to the power of 1. Then we can rewrite the even powers using this trigonometric identity, this Pythagorean identity right here. So everything is going to be rewritten in terms of sine except for this 1 power of cosine. And if you do that, you can use u sub and you set u equal to sine, because if you use that strategy, du is cosine of x dx. So that 1 power of sine that you left out will substitute out when you do your u sub. So that's our strategy if you have an odd power of cosine. Very similar strategy if you have an odd power of sine. You're going to just pull out 1 power of sine and replace all of the rest of them using this form of the same trigonometric identity. This is just sine squared plus cosine squared equals 1 rewritten. So if you rewrite everything in terms of sine except for that 1 power, and you set u equal to cosine, when you do your u sub, du is negative sine of x dx. So this power of sine that you left out will substitute out when you do your u sub. If both are odd, you can pick either strategy. You can replace all but 1 power of cosine or all but 1 power of sine and substitute appropriately. But if both are even, in this case, you actually can't use this strategy. You can't use u sub. But what you can do is you can reduce the powers of sine or cosine using your trigonometric formulas here. So here's the power reducing formula for sine squared. Here it is for cosine squared. You'll notice that they are very similar except for sine, it's negative, and for cosine, it's positive. So here's just a quick reminder of our derivatives that we will be using with this u sub. All right, so let's take a look at this first example together. So here I see that we have that odd power of sine. So we know that we can rewrite our trigonometric functions whenever we have an even power, if we have sine squared or cosine squared or any other even power. So whenever you have that odd power, hopefully it stands out that we should rewrite it. So I'm going to leave aside 1 power of sine, which I'll kind of put at the end, and that leaves us with sine squared of x times cosine squared of x, and then again, I'm just going to kind of leave this last power at the end with dx, and you'll see why in just a second. So from here, I want to rewrite any other powers of sine using our trigonometric identity. So 1 minus cosine squared, and then we still have the cosine squared, and then we still have our lone power of sine. So from here, now I'm ready to set up my u sub. I can clean all of this up by setting u equal to the cosine of x. And here's why, again, we set aside this single power of sine, because du is negative sine of x dx. So we'll just move the negative to the other side, and this allows us to do a pretty nice u sub. So we'll put the negative out front, and then I have 1 minus u squared times u squared du. So all of this that we set aside substitutes out when we do our u sub. And then from here, we can distribute, and then we have something that's pretty easy for us to finish integrating. So we have 1/3 u cubed minus 1/5 u to the 5th. And then that will be plus c. And then all we need to do from there is substitute back in for u. So we have negative 1/3 cosine cubed of x plus 1/5 cosine to the 5th of x, and then plus c. So again, our whole purpose of setting aside this single power of sine is so we can set u equal to cosine, whose derivative is negative sine, so it cancels out. So we do this very strategically at the beginning because we know we're going to be using u sub. All right, let's try another one together. So here we have an odd power of cosine. So I'm still going to use that same strategy. I'm going to set aside 1 power of cosine, which leaves me with cosine to the 6th of x, and then we have cosine of x dx. So again, I'm setting this aside with the intention of later knowing that I'm going to set u equal to sine of x, and I know that du is cosine of x dx. So this portion right here is going to substitute out. But I now need to rewrite this in terms of sine so I could use my u sub. So we can do this with the Pythagorean identity. If it helps, we can start by writing this as cosine squared of x and then cubed. And then here's the one we set aside. And then this we can rewrite as 1 minus sine squared. So 1 minus sine squared of x and then cubed cosine of x dx. And now we're ready to use this u sub, so that gets replaced right here. So we have 1 minus u squared, all of that cubed, and then du. So for this, to help us integrate, we are going to want to expand this binomial out. It does help if you remember your binomial expansion, but it becomes 1 minus 3u squared plus 3u to the 4th minus 1u to the 6th, and then all of that is du. And then once you've expanded out that binomial, this is a pretty straightforward one to integrate. This just becomes u minus u cubed plus 3/5 u to the 5th minus 1/7 u to the 7th. And then, of course, we have our constant of integration. And then we just substitute back for u. So we have sine of x minus sine cubed of x plus 3/5 sine to the 5th of x, then minus 1/7 sine to the 7th of x plus c, our constant of integration, and that is our general antiderivative. All right, here's one for you to try on your own, so please pause the video and give it a shot. All right, go ahead and check here. So you can see that I set aside the single power of cosine, and then I rewrote everything else in terms of sine. So if I set u equals sine of x, du is cosine of x dx, and it simplifies out really nicely. You do need to expand this out, distribute, and then you can integrate. All right, so here's a case where we have 2 odd powers. So for this one, you can use either strategy. We're actually going to try it with both. So let's say first I want to set aside a power of sine. So I have sine squared of x, cosine cubed of x, and then I have sine of x dx. So if I'm setting aside a power of sine, that means that I'm going to be setting u equal to cosine of x, because negative du equals sine of x dx. So that means I need to rewrite everything else in terms of cosine. So I have 1 minus cosine squared times cosine cubed, and then my single power of sine. Now I'm ready to do my u sub. So I have 1 minus u squared times u cubed, and then all of this will substitute out, and I'll put that negative right out front. So from here, we'll just distribute. So u cubed minus u to the 5th du, and then we can integrate. So negative, and then we have 1/4 u to the 4th minus 1/6 u to the 6th plus c, and we'll substitute back out. So negative 1/4 times the cosine 4th of x plus 1/6 cosine to the 6th of x plus c. Now, let's say alternatively, I wanted to set aside a power of cosine. So that would leave us with sine cubed of x, cosine squared of x, and then we have cosine of x dx. So if I'm doing this, if I'm setting that aside, I'm doing it with the intention of setting u equal to sine of x. So du is cosine of x dx. So that means I need to rewrite everything else just in terms of sine. So we have sine cubed times 1, sorry, I forgot my x, times 1 minus sine squared times cosine of x dx. Now I can do my u sub. And I have 1 minus u squared du. So all of this substituted out for du. Let's distribute, and then I can integrate. So 1/4 u to the 4th minus 1/6 u to the 6th plus c, and then we'll substitute back in for u. So 1/4 sine to the 4th of x minus 1/6 sine to the 6th of x, and then plus our constant of integration. So you can see that we do have two different answers, so it depends on which strategy you use, but actually if you do the steps of rewriting either in the form of the other, you'll see that these are two completely equivalent expressions. So whichever way you do it, they are both correct. You don't need to do it both ways. So again, when both degrees are odd, you can pick either strategy, whichever one you prefer. All right, so now we're going to try one where both powers are even, and unfortunately these aren't quite as nice and easy as the other one. So we will start by using our power reducing formulas to rewrite sine squared and cosine to the 4th. So for sine squared, that's 1 minus cosine of 2x over 2. And for cosine, well, cosine squared would be 1 plus cosine of 2x over 2, and then all of that is squared, and then we have dx. So here I'm just going to pull out my my constant. So we have 1/2 times 1/4, so I'm just going to pull the 1/8 out front. Then that leaves us with the integral of 1 minus cosine of 2x, and then I have this binomial squared, which I'm actually just going to write it out like this, and you'll see why. It's because when I start to multiply out these binomials, which unfortunately I do have to do, you'll notice that these are conjugates. We have 1 minus cosine of 2x and 1 plus cosine of 2x, so it's actually nicest to start by multiplying those two together. It'll just make your job a little bit easier. So we have 1 minus cosine squared of 2x times 1 plus cosine of 2x dx, and then I'm going to keep multiplying this out. So I have 1 plus cosine of 2x minus cosine squared of 2x, and then minus cosine cubed of 2x dx. All right, so from here, some of these parts I can integrate, some I still need to do a little more work. So I'm actually going to start splitting it up using my sum property of integrals. So I have 1/8 integral of cosine of 2x minus 1/8 times the integral of cosine squared of 2x, and then minus 1/8 times the integral of cosine cubed of 2x dx. So I know this first one I can integrate, so it's just going to become 1/8 x. And then from here, I can also integrate this one. I'll have 1/8 times 1/2 sine of 2x. So that one's not too bad. For our next one here, we're going to kind of use the strategy we started with, and I'm still have my integral. I'm not integrating yet. I'm going to rewrite it again using our power reducing formula to get rid of the squared. So it becomes 1 plus the cosine now of 4x all over 2, and I'll work more with that in the next step. And then in our last integral, so we have minus 1/8. Here, I'm going to use that strategy that we learned today. So if I have an odd degree of cosine, I'm going to set aside 1 power of cosine with the intention of setting u equal to sine of 2x, and I'll work with that in the next step. So now I'm just going to work with this integral. So let's finish this one before I get to this last one. So here we're going to want to start by splitting up our fraction, so we can rewrite it as 1 over 2 plus the cosine of 4x over 2 and all of that dx. And then this should be something that we can now integrate. So it will be 1/2 x, and then here we have the 1/2 that we want, and then we would multiply by 1/4, and then the sine of 4x. So we're kind of working with the chain rule as well. All right, and let's move over to our last integral. So remember here, our plan was to set u equal to sine of 2x, so we need to rewrite this first. So we have 1 minus sine squared of 2x, and then we have our single power of cosine and then dx. So now we can do our u sub. So we're going to set u equal to the sine of 2x. So that means that 1/2 du equals the cosine of 2x dx. So it would be 2 cosine of 2x dx, and then I just moved the 2 over to the other side. Okay, so now I'm ready to actually do my u sub. So that would give me negative 1/16, and then times the integral of 1 minus u squared du, and then I can evaluate that integral. So u minus 1/3 u cubed, and I'm just going to add the plus c at the very, very end. So now I have negative 1/16 times the sine of 2x minus 1/3 sine cubed of 2x. All right, so now we kind of need to zoom back out and look at what we have. So here's the parts that were already complete. So we have this portion here, this portion here, and this portion here. So now it's just kind of a matter of piecing it all together and combining like terms when we can. So it leaves us with 1/8 x plus 1/16 times the sine of 2x minus 1/16 x minus 1/64 sine of 4x. So here I'm just distributing this to this term and this term. And then my last portion gives us minus 1/16 sine of 2x plus 1/48 sine cubed of 2x. So now we're just going to, and then I'm going to add in my constant of integration. So don't forget that at the very end. And then here I can start combining like terms. So I do have 1/16 x, and that takes care of these guys. You'll notice here that these two terms will cancel out. And then all I have left is minus 1/64 sine of 4x plus 1/48 sine cubed of 2x and plus c. And then I am finally done. So you can definitely see when we don't have that odd degree of cosine or sine, again, these problems are just a lot uglier. Sometimes within that problem, as we did right here, we end up with that scenario where we have an odd degree of cosine or sine, so then we could still use our strategy. Sometimes we end up with another even degree, so we have to use that other strategy of using our power reducing formula. But yeah, I mean, this one, it is a little bit tedious, but if you know the strategies to use, you should be able to get through it. All right, so I have one last one for you to try on your own. So pause the video and give it a shot. All right, go ahead and check your work here. So you can use your power reducing formula to rewrite this like this. So 1 plus cosine of 2x over 2, all of that squared. So it's like saying cosine squared squared. And then we could pull out our constant and multiply out this binomial. So if you split this up into different parts, this is something we can integrate. This is something we can integrate. This is something we'll need to rewrite again using our power reducing formula. Be careful, this one is 1 plus cosine of 4x because now the angle inside is already 2x. And then we can pull out our constant here, and this is now something we can integrate. So that gives us x and then 1/4 sine of 4x. And then from here, it's just a matter of distributing and combining like terms. All right, so that is all for today's lesson. Thank you so much for watching.